Hello, and welcome to this edition of the Secure Networks, the Endace Packet Forensic Files, with your host, Michael Morris. This episode's very special guest is Eric Buchaus, Director of Sales at Niagara Networks. Eric, welcome. Thank you for joining us. Tell us a little bit about yourself and your background.
Well, thanks for having me, Mike. I'm excited to be here. Watched a lot of your podcasts, so I'm excited about that. I feel like a rock star now with all the folks that have been on there. But yeah, a little bit about myself. Been in the technology industry for 20 some odd years. Owned a hosting company for many years. So I've been in the hosting / cloud environment for many years. So in director of sales here at Niagara Networks for the last 2.5 years now. Been doing well here on that side, but yeah, that's a little bit about myself.
No, Eric, we're excited to have you with our series. I know you got a ton of expertise in the networking space, and when we were talking the other day, one of the things we wanted to get out there for our listeners is really kind of answer that age-old question: is span ports good enough for network performance management or security management? And should SOC teams and NOC teams really be leveraging taps and packet brokers? So I'll start with that question.
Sure. So, span has its place. It is good. It's a good start, if you will, if you're really looking for performance monitoring or you're wanting to send that data to a NDR tool or something like that you really want to look at that data. There are some challenges with span, natively within the technology. Okay, so if you've got a 40 or let's just say a 10 gig switch port, you've got 48 ports there. If you're at line rate, you're at 4.8 terabytes of data, and you're trying to push all of that data out one 10 gig port. So you're going to have some limitations there. You're going to want to put some QoS or something on that switch to make sure that your data goes to your product, as opposed to the span port on that side. So you're going to have traffic congestion. You're going to have latency within the span ports. You're going to have, a single point of failure, of that port. Limited visibility on that side. So, and I guess the big thing here is really going to be around the security risk of that span. So if, say, you get breached, that span port's going to be able to access everything out there. So, so you're adding an extra layer of security potential issues there, but when you're really talking about like an NDR tool or anything of that nature, specifically with span, you're not going to see all of the data. So NDRs usually want to do a full deep packet inspection. If you're not seeing all the data, how are you going to do a full deep packet inspection on that side? So this brings us back to taps on that side. So why would you want to tap it compared to span? A tap is going to take a complete full copy of every packet that passes through the tap. So it's not going to be a best effort. It's not going to be, well, we'll get it. And if there's, a congestion, we're going to keep our line available as opposed to sending it to the span. We're going to get every packet that's out there. So you're going to get full visibility on that side.
No, those are some great points you nailed there on the risks. And I really think this is useful for our listeners to understand some of these differences. Can you educate them on some of the different types of taps, packet brokers, and inline bypass solutions? Because I think there's confusion and uncertainty in the market of when what is needed.
Sure. Well, everybody knows, let's take it back one step as far as what type of cable. You've got copper or fiber out there, you're going to want to tap that network. So there's two different kinds of technologies on that side. And then we also have some virtual taps in the market where you can look at, your public cloud or your private cloud, something along those lines, similar to a port mirroring type of thing.
Mm-hmm.
Some ins and outs and some nuances with let's start with fiber taps. Okay, those are the easiest that are out there. All it is a light prism inside of a box about the size of a dollar bill. Okay. And all it does is split that signal. And those of us that are old enough to remember coax splitters to run coax to different rooms so you can have cable TV in different rooms, it's exactly all it is. It's exactly what it is. It just splits the signal. The exact same signal goes both ways. There's different nuances there we won't get into, but essentially that's the theory behind it. Then we talk about copper taps, a little bit different because you know as well as I do, copper takes power to generate that signal. So you can't just put something in the middle to sniff it or to split it without regenerating the power to continue on to its destination. So you would need to put a copper powered tap in between. Some nuances there is that if it's in between and that device fails, your line fails. So that brings me to the third point you were talking about, I think, inline bypass. So the inline bypass is exactly what you need in this situation. So if, say, for instance, that copper tap were to fail, you need something to bypass that device to keep your line open or failed open or however nuance you want to call it, failed open, failed closed, whatever that means to you. But you just want that data to get to its destination without it being dropped. So you've got two different types of taps there. Copper and fiber, but let's talk about virtual taps on that side. Virtual taps are, like I said, in any of those hyperscalers or VMware environments, they do the exact same thing. They'll just take a copy of whatever packet's going in and out and send it to a network packet broker. Now, packet brokers, a lot of people are wondering, are you selling me data like the old T1 type of things, and network interface brokers? No. What it is a lot of people call them tap ags or network aggregators, stuff like that. Look at it as a funnel for your network. We're going to gather all of that data from your network, whether it be from taps or span or whatever. We're going to aggregate it all into one spot. Most aggregators out there or tap or network packet brokers are going to filter that data. They're going to look and strip out things that are known that you really don't need in an inspection, like headers or footers, or say, for instance, you want to filter out streaming video. There's nothing executable, so why do I need to look at it? Or SIP traffic. It's like, it's a phone call. I don't need to inspect that. You can filter a lot of that stuff. You can and then send the good payload to a tool to inspect on that side, whether it be a troubleshooting tool like Wireshark or any other NDR type of tool on that side. Whatever you need to do, any type of monitoring and stuff like that, you get the good payload on that side. And then, of course, inline bypass, very important, kind of a different workload on that side than a tap and aggregation. The inline bypass is important in some respects on the tap side, as we mentioned earlier, but if you've got an IDS system out there, you don't want an HA IDS because that can get quite expensive. That usually sits kind of sometimes out of band or sometimes inline. So you would want some type of bypass to bypass that device in order to, in case that device fails, a heartbeat fails on that device, similar to you're driving, you see the gates go down at a railroad track and the train is stopped. How do you get around? You want to bypass it. Exactly the same theory, but we're using technology to bypass that. That's long-winded, sorry. But
no, it's a great breakdown of all. It's a lot to know, right? And this is, again, why we want to share with our listeners. So let's take it, because you mentioned virtual a little bit. As you and I both know, a lot of organizations are moving specific workloads to cloud environments, specifically public cloud environments. So what are some options in public cloud, like AWS, Azure? I know you guys have some stuff there. What can you educate and how can people have that same network visibility in cloud infrastructures?
Sure. Yeah, the three hyperscalers that we all know, AWS, GCP, Azure, they all have their own homegrown type of technologies to do, whether it be port mirroring of some sort. AWS has VPC traffic monitoring. So, they can monitor traffic Azure has their own flavor of it. GCP has like Google packet mirroring or um, something along those lines. So I mean, they have their own homegrown tools. There's limitations to them. They only give you similar to, dare I say, like a span feel to where it's not going to be everything and everything that you need out of there. And again, you're gonna, well, I should say in port mirroring or any type of mirroring, you're going to get everything. The problem there in those public clouds is, what is your biggest expense in a public cloud? It's usually the bandwidth. So if you're
data
setting
offload,
that, right, if you're sending that bandwidth, through your application and serving, doing all of your workload, well, guess what? Now you want to do mirroring, you want to look at all that data, you're paying twice. So, I mean, it could end up costing you several thousands of dollars in double bandwidth, essentially, because now you're pushing it in and out twice. Now, where some tools that are out there, there's some cloud native tools that are out there that aren't really, Google tools. We have one too. We have a cloud broker that's out there, if you will. Some of our competition also has similar things. There's not really a secret sauce there, but here's some of the benefits, whether you use ours or anybody's. Benefits there is you're going to be able to cut down all that bandwidth. Again, do all that stripping of headers and all this other stuff, drop the stuff that you really don't want to see, and it's going to cut your bandwidth 40 to 50%, pushing that data in and out. Some secondarily, if you don't want your inspection tool to live in the cloud, you want it in your physical environment, you would pull it back into your data center or where the tool sits, so you don't have multiple tools out there. So there's huge benefits there. So that, yeah, there's a ton of tools that are out there to help you with this, whether it be AWS, or if it's, hybrid, or if you've got a container-based environment or anything like that. You can, there's tools out there for each application, and it's usually customized for your workload.
Are customers able, and I know this is one of the benefits of why we work with you guys, are customers able to broker and see traffic both in on-prem and cloud environments? And you did essentially answer that in the last question. But one of the things I know that is a benefit in our combined solutions is really the ability to broker it on-prem and broker it in the cloud and keep them in those infrastructures so you're not paying for those offloads. Can you maybe elaborate on how you're doing that in some real customer environments?
Sure. So we've got a number of clients doing exactly that. They have a hybrid environment, or they've got environments with small satellite locations, type of thing. So it doesn't warrant having a large footprint of gear at a at a location with 10 people, so I mean, spending, dare I say, a couple $100,000 to do network inspection on 10 people is not fiduciarily responsible on that side. So yeah, we, like I said, when you're looking at a public cloud or environment like that, there are several tools out there that offer a cloud inspection environment stuff. So as you know, with that living within their environment and on a VPC or an Azure instance or whatever type of virtual instance at whichever hyperscale, you can actually put their tool, their sensor, all that kind of stuff or whatever at the source, so then you're not paying any of that bandwidth on that side, except for, say, a log or something like that, or here's what we have found, and they're talking back and forth with their home inspection tool at a physical on-prem environment, if you will. So
right. Well, and that's key value of what you're providing there is the ability to see that information in either environment and not have to pay those offload charges or upload charges, right? So you nailed it on the head there. You mentioned earlier there are many tap and packet broker vendors, right? You're one of them.
Sure.
But what are some considerations you recommend organizations really look at when looking at vendors in that space?
Sure. Well, I guess the first thing that I would recommend is really define your specific use case and your requirements. Just like at home, you're going to define a budget for your home, and hey, we got this coming in. I want a boat. I want a new house. I want a lake house. Well, how do you accomplish that? Well, we've got to do this, cut that. You've got to come up with your requirements and define how you're going to accomplish that and what you really want. So that's key in all of this. You want a business plan of what you're looking to accomplish. That's first and foremost. And once you've defined all of that, you're going to want to go and look at vendors. Look at us, look at all of our competition that's out there. You're going to want to look at, how are they scalable? Are they compatible with your environment? You've got Palo Altos and you've got Cisco and you've got Meraki in there. Can they work with all three? Can they network in all of this? Just throwing names out there as far as that's concerned. Look at the feature set that they're offering you. Does it align with what your requirements are, your use case? Are they going to give you the data that you want? Is it reliable? Do they have redundancy? How do they perform? Are you looking at dare I say Google reviews on them? Are they a good product out there? Are they have you called their support line to see how they respond? That type of thing. What is their costs? Not to race to the bottom, but what is their cost to all of the things I just mentioned there? And then, of course, the final thing I would do is, require a proof of concept. Go grab their box, kick the tires. You're not going to buy a brand new car without driving it. So, right. So kick the tires of it. And worst case scenario, I should say, is it's going to add some time, but do a bake off. Get them out there with, with 2 or 3, streamlined vendors and go that route, and figure out exactly the fulfillment of those requirements that you defined right at the beginning.
Right. No, I think that's an honest, open approach, right? I mean, obviously, sure. There's lots of considerations, and you nailed it in terms of looking at your key requirements, looking at your budget. So one question right. we hear a lot, and I'm sure you do as well, is how do various tools that you're feeding handle encrypted traffic? And so what are some options for our listeners to really think about or consider there?
Sure. Well, encryption is a beast, not just for us, but I think for anybody that's out there, because, decryption of encrypted data, whether it be TLS, 1.2 or 1.3, there's different ways of handling it. 1.3, you have to have a man in the middle approach, because it's intended to keep people from sniffing traffic. That's the purpose of it. So how do you sniff traffic that is intended not to be
right.
sniffed? Yep. So how do you do it? So you're going to have to play man in the middle, get the keys, regenerate the keys. So it is a beast. And by doing that, again, it takes a lot of resources in order to do that. So, if specifically with us, some of my competition may have other different ways of approaching it. But if you're looking for your entire network is encrypted, probably not a good fit for you, just because the amount of data and the amount of resources you need to decrypt all of that, you're really going to want somebody at the edge like a Blue Coat or something along those lines to really decrypt all of that, because it's such right. high bandwidth, that type of thing. However, if you've got an app server talking to a database server and it's encrypted and it's, say, a gig of traffic a second or something, then yes, we can actually grab that traffic, tap it, we can decrypt it and send it off to the tool, a similar fashion to right. everything else, but there's just a decryption mechanism in between there. So if there's strings like that or sessions that have some encryption, anything like that, then yes, there's ways of doing it. Again, it's unique to each environment. It's not a plug and play. It's not a here, just plug this in and you can now decrypt. No, there's definitely some customizations. And I think we talked, several times before, Mike, and your professional services background there, it takes some professional services to set that up. So
you nailed it.
Yeah.
Again, it's a complex topic, and you've really got to kind of architect how you want to provide the data to the various tools that may need it and what they can do with it. So, similar kind of follow on, you mentioned data volumes and scale a little bit ago. We were talking about, dynamic SDN networks a little bit in our kind of prep for this interview. So how does architecting a solution or an infrastructure with taps and packet brokers really aid and help in handling data volumes and dynamic networking?
Sure. And I think this goes back to our virtual taps. I mean, taps are going to be very important in this type of environment. One of two things. Virtual taps are transferable. So when you're talking about software-defined networks, it's going to be highly programmable in that sense to find out exactly what is going on within your environment, where things are, and dare I say, let's go to a VMware environment type of thing. What is it called? vMotion or something like that. You're going to want that tap to follow that string. For instance, that host goes down, but the string is still alive, or that session's still alive. They just beam it over to another location. You're going to want to look at that. It comes down to the visibility into those virtual environments. Aggregating all of that stuff within a software-defined network is just difficult to see if it's a span, because where did it come from? Where is it going? Because by the time you get back, to go and fix the issue, it's somewhere else, at that point in a software-defined on that side. I think that's what I have for that.
And you already nailed the data volume, right? Eliminating unneeded traffic to go to tools, whether it be video traffic or you even talked about SIP traffic, things like that, right? It's making your tools more efficient by handling it and handling it within a dynamic network. It clearly makes a case for don't depend on spans. It's the case I'm hearing you say. So yeah, no, absolutely.
Right.
So kind of shifting just a little bit, zero trust environments is key. We're hearing a lot about, right? Which involves network segmentation or walled gardens, a lot of VLANs. There's a lot of IoT medical environments. What challenges does that present, and how do taps and packet brokers really help in those areas, right? Because now you have a lot of network segments, right? Which means more chunks or groupings of data to be sent to different tools. So how does solutions like taps and packet brokers really help in those areas?
Sure. Well, I mean, we know the challenges of IoT, network segmentation and stuff like that. First, I mean, IoT creates a significant amount of traffic. It's just a ton of traffic that's coming in, which can be challenging to analyze, effectively, So, I mean, the big thing that you're going to want to do is isolate that traffic, just like in a zero trust environment. Trust nothing until until it's good. But that again, gathering that traffic to be able to test and stuff like that. How do you get that through? So it could be, security taxing, I should say, because again, you don't want it through, but you also want to look at it. So what do you do there?
Right.
So in taps on taps and network packet brokers, help with IoT segmentation, so again, you're out of band, you're out of line type of thing. So you're not on your production network. Let's take it off so we can help you filter that traffic and decipher what this traffic is with, network NDRs or anything of that nature to figure out what you want to do. And then put those rules in to say, yes, this is good, that's good, all that kind of stuff. Helps you, filter and load balance, the traffic flow, helps with security inspection, helps you with VLAN isolations and, a number of different things that you're going to want to put in place in order to keep that IoT traffic safe, but also adhering, dare you say, zero trust. A lot of medical facilities out there. Zero trust is now it's going to be the next HIPAA, so I mean, it is in some respects, but
you absolutely nailed it. And just simply the port density, right? Getting all those, now you got multiple segments, multiple VNICs to or NICs, not necessarily VNICs, to get. And so I think you nailed it. So, Eric, one question I like to always wrap up my interviews with, ask you to be a little bit of a prognosticator and look out 6 to 18 months in the ever-shifting battle for cybersecurity and network security. What's one thing you think our listeners should be keeping their eye out for?
It's kind of a two-part answer to that. I mean, we talked about it a little bit here. Embrace zero trust. Around security, whether it's medical or not. Zero trust because you don't know what's coming to your network. You're not just gonna open your door to your home and leave it wide open. You're going to keep the door shut until you see who's on the other side, type of thing. So zero trust on that side. But with doing that, you need to make sure you're incorporating some type of AI. I know we really didn't talk about that, but make sure that's in the discussion to help, with combating these new attacks, because as well as I do, a slingshot against a machine gun, the type of thing is not a battle-born.
It's a good analogy.
So
that's a great analogy.
Right. Yeah. So probably not at this time, probably not a good time to bring that up, but in any case, but again, if you have AI out there helping you combat some of these security risks, stuff like that, while embracing that zero trust, I think is probably where things need to go. A lot of people are scared of AI. I get it, machine learning and AI, I get it, but it's out there. So, I mean, how are you going to combat it if you don't combat it with itself? So that's really what I would focus on. Or that's where I see things going in, say, the next 6, 12, 18 months. So
no, those are two excellent points you brought up there, Eric. Eric, thank you for joining me, sharing your tremendous insights in how to better secure networks. We'd ask our listeners to tune in next time for another edition of the Endace Packet Forensic Files. For more information about Endace's network packet capture platform and our integrations with our Fusion partners, Fusion technology partners like Niagara Networks, please go to endace.com. Eric, again, thanks for taking the time. Really appreciate it.
Yeah. Thanks for having me. Appreciate it.